Hello everyone, today I am going to deliver a lecture on approximate lateral load analysis by cantilever method. The approximate analysis of a statically indeterminate structure by cantilever method. So I will cover the assumption of cantilever method of multi-story structure, and then I will try to cover the formula derivation of cantilever method for multi-story structure, and then the important thing is example of analysis of multi-story structure by cantilever method. And last one, I will try to compare the result between portal method and cantilever method, as I have been seen in the most of the shear force and bending moment value in cantilever method is greater than portal method. Okay, I'll see all of this. So let's see the first assumption. First topic, which is assumption of the cantilever method for multi-story building. Okay, let's start. So I have been taking this note from Professor Dr. Iftikhar Anam sir, Professor University of Asia Pacific, Dhaka, Bangladesh. Okay. So let's see the analysis of multi-story structure by cantilever method. So although the results of being a portal method are reasonable, most cases uh, the method suffer due to lack of consideration given to various structure response different between sectional properties various members. The cantilever method is rectifying the limit by considering the cross-sectional area of column distributing axial force in various column of the stories. Okay, this was the some basic what I will say theory. So if I go to the Hibbeler books, structure analysis Hibbeler, so you can see why the cantilever method we have used, not the portal method. So we can see that for large for the tall building we have been used the cantilever method. So see here, the cantilever method is used for the same section as the long cantilever beam subjected to transfer load. So it is same action the long cantilever beam as it is made recall from the mechanism materials loading causes bending and stress in the various form of the neutral axis. Okay, we can see the cantilever method is transfer appropriate uh, the cantilever method is therefore appropriate if the frame is tall and slender. So these are the main I can see the information it will tall and slender or has a column or columns with different cross sections. Okay, let's see here the some following assumption based on the Hibbeler book. The as the hinge is placed at the center of the each girder, since this assumed to be point of zero moment. As a hinge is placed at the center of each column, since this is assumed to be a point of zero moment. And last one we can see the axial stress is column is proportional to the distance of the centroidal axis of the column. So we can see another reference book is Reddy Chet, C.S. Reddy. He is also given the assumption which is the end inflection point is located in the mid of the column of the each story. So if we go to the my slides, and you can understand what I mean it. Cantilever method. Okay, this is the hinge is placed at the center of the each girder, since the assumed to be point of the zero. This is the girder we can see, or beam. And another number two is the hinge is placed at the center of the each column. This is the each column we've been seeing here. The axial stress is column proportional to the its distance from the centroidal cross sectional area of the column at the given and liberum. So you can see that two column is given. So this is the CG, or center of gravity of the from portion. Okay, so we can see here from Iftikhar Anam sir here the cantilever method is three assumption. He is also giving the same assumption. Firstly, axial force of each column is proportional to the horizontal distance from centroidal axis of the column columns of the story. That means I have been seen here. This is the two column and this is the CG from same distance. And there is a point of inflection center of the each column. So I have been shown here. The each column is centroidal inflection, and there is a point of inflection of center of the each beam. So I have been shown here the inflection of each beam. Okay, so assumption one is based on assumption one is based on assume that the axial stresses can be obtained by method of analogous to obtain use the determining and distribution of normal stress on the transverse section of the cantilever beam. And assumption 2 and 3, which is the inflection of each center column and beam based on the observing the deflection shape of the structure. Okay, so our assumption has completed. Now we can now we can see the formula derivation of cantilever method of multi-story building. So let's go to the formula derivation, how the formula derived from the portal. We can see a picture, the formula derivation of cantilever method lateral analysis. You can see a lateral load is applied in the left side of the top of the structure, and the height is given is which is h by 2, and section is given a1, a2, a3 and a4, and we have been taken the CG, which is center of gravity, is taken at the point of Z. So you can see this is the distance of from CG to A1 is x1, and CG to A2 to x2, CG to A3 is x3, CG to A4 is x4, and P1 P2 is in downward. In similarly, in this case P3 P4 is upward. Okay, let's see. We can see the stress divided by centroidal distance. Stress means force per area. So if we take this this member, which is stress force per area divided by x1, this is the x1. For the second member, which is stress P1, stress force per area into x2, and force per area, this is the force per area into x3, and force per area which is P4 divided by f4 in x4. In this case, we have been rearranged and found P1 P1 A1 P1 divided by A1 x1, and P2 divided by A2 x2, and P3 divided by A3 x3, and P4 divided by A4 x4. So if we rearrange only to this portion, so how will get, if we take the P2 is here, so this portion is gone out in here, so it will be P1 A1 into A2 x2. This portion will be multiplied with this portion. In the same case, we have been taking the if we compare P3 A3, because the wall are equal, that's why we just compare. Then you can we can find P3 to A1 A2 A3 x3, and same way for P4. Now we are taking the moment at Z. We are taking the Z, this portion from this point. We are taking the moment force in perpendicular distance P into F into h by 2. So we can see F into h by 2 minus P1 x1. This is the P1, and x1 is distance, and P and P2 in x2. And in the same way, we all the taken all the force into distance is taken here. And we can just rearranging here, and we just seeing here P1 x1. So P is given here, and A1 x1 is extra, and A1 x2 is, if we cancel out, then it will be only x1 will be remain here. That's why you are taking here. So if we taking P2, we have been found the below P2. This is the below P2. I'm just changing the color. This is the below P2. So we are just this P2 below we are adding here here P1 A2 P1 divided by A1 x1 A2 x2, and it will be multiplied with x2, and this will be x square. So in the same way, you are taking the P2 below P2. We are taking here P2. We are taking the wall, putting the all the values here, and finding this here, and we are all taking the from equation 1. Okay, for if we take the P1 A1 and finding this value, the rearrange, and we will find this value. now we are seeing here, if we calculate, if we want to P1, then the formula will be here F1 F into H divided by 2, and it will be multiplied with A1 X1. This is here, and this portion will be downward. So these are the our formula derivation. We will see the how will we can see the formula derivation. Now we can apply the formula, how we'll apply the formula, or we can see the example of the multi-stories building. Okay, so let's see this. This is example. We can see here, use the approximate method to cantilever method to draw the axial force, shear force and bending moment diagram for the 3 stories frame structure loaded and shown. So we can see here, we can see here the all the information is given is 18 12 6, and height is 10 10 12, and the distance of 15 10 15. So so we can let A is same for the wall column, so we can see all the column is same. So at first we have to take the CG. We know the how we'll calculate the CG, summation of A1 X1 into summation of A. So we are taking this CG for second floor. This is the ground floor, this is the first floor, this is the we can say it, second floor. But in the wall floor, the CG is same for wall floor. Okay. Okay, we are just taking the CG from here, as the wall section is here. So we can see X prime A1 into A1. This is the A1, and the distance, as we are taking the moment from this point, that's why the distance is 0. For A2, this is the A2, the distance is 15, and A3, which is all are A, that's why we are taking we are writing A, not A3. A into the distance of here, so 15 into 10, it will be 25, so 25. And last one we can see A into 40. How will get the 40? The distance 15 to 10 into 50, it will be distance is 40. Okay, so in this way you can find out the CG is 20, so it will be 20. This is 15, and this is 10 divided by 2, it is 5, so it will be this is the our CG distance, which is X bar is 20. Okay, so now if we get the distance of CG, then we can easily calculate from CG to this first column is X1, which is 20, as taken here 20, and X2. So CG to the second column is distance, so you can find 5. So this is X2, and X3 will be CG to third column, which is X3, and CG to last column will be X4, which is 20. So these are the main important to find out the CG and X1, X2, X3, X4. Okay, now we can find out the axial force, which is P, which is we know the force PMI. So this column MI, I just change the color. So AMI, this portion, we know the AF divided by H by 2, A1 X1 divided by AX1 square plus AX square 2 plus AX square 3 plus AX square 4, as we have been shown in previously from the derivation formula. So we can see how we'll apply this. So these are our formula derivation, it is taken from here. So putting this all the value, F is given 18, and H by 2 is 10, as we will know this is the 10 divided by 2, and A1 X1 A1 is found A is constant, as we know the all the column taken the same. X1, as we have been taking the 20, this is the 20, and X2, as we know the X2 is 5, and X3 also 5, and X4 is into 20. After the putting all this value and found PM1, this the axial force will be 2.112. So in the similarly we can calculate PNG, this column. I will calculate. We can calculate P1 divided by A1 x2 plus A2 x2. These are taken from this formula, as we have been seen the derivation of formula. So P2 will be K. The all the remember that all the member we are taking P1 divided by A1 x1, and it will be a2 x2 or a3 x3 a4 x4, but the first portion will be remain same. That's why we are taking p1 a1 and for another okay this portion p1 a1 also, and last one p1 a1, so this portion are remain same. And a2 x2 for p and g, a2 x2 are the remain same. And p1 we know the value, we have taken 2.12, and a1 is no a is remain same, and x1 value have been found 20, so we are putting 20. And a2 is a2 is as we have been taking the all the same section. And x2 is 5, as we have been finding 5, or from this picture we have been finding 5. And in this case we have been found p and g, which is 0.53. So this is the 0.53 for the axial load. And the same way p okay from this o and k, and putting a1 divided by x1, p1 divided by a1 x1, and a3 into x3, putting all this value and found 0.53. p1 value is 2.13. This is the 2.12 a, and x1 is values 20. We are taking x1 and 20, or we are taking here 20. And x3 we have been taken the 5 and found 0.53, 0.53. And last one we can see p1 plg, so this portion pl, and putting on this value, p1 is 2.12, this is the 2.12, and x is 20, and a is a, and x4 is 20, and found 2.12. And for first floor, this is the ground floor, this is the first floor, this is the second floor. So our second floor is done. Now we can calculate the first floor in the same way. So at first we have to taken the x bar as the wall, this is the regular building. That's why the x bar, x1, x2, x3, x4 will be remain same. If the if the value of change of a section and distance and irregular shape, then it will be change the CG and A1, X2, X3. And the same way we can putting all the value here and finding 7.76 and 1.94 and 1.94 and 1.76. Okay, so let's see the last the ground floor. This is the ground floor. In the same way you can calculate CG, then x1, x2, x3, x4 from this building, as we have been finding in firstly. That's why the same value. If the irregular shape, what does mean irregular shape? This is if the building is act like this, then the CG of ground floor will be changed. X1, X2, X3 also change, for each building will be changed. So that's why we have to calculate again and again. But the shape is building is regular. That's why all the CG and X1, X2, X2 value is in all the stories is remains same. Okay, for so in this case we have been taking the putting all this value here and founding 16.38 and 4.09 and 4.09 and 16.38. So let's from this case we have been seeing the first the second floor, as we have been finding. This is the second floor, the axial force of the second floor. At first we have been found PMI, which is this portion, and found 2.12. So we have been taken 2.12 and 0.53 and 0.53 second in consecutively 0.53. I'm just changing color for your better convenience. So this is the point 53 for this this two column. So 0.53 is given here and 2.12. So last one 2.12. So in this case, in this way, so just changing color here for first floor. So we have been found 7.16. So these are the first floor, as you've been taking at the ground floor, first floor, and second floor. So first floor we've been found 7.76. So it will be 7.76, and then 1.92 and 1.94, 1.94. These are the 1.94, 1.94, and last 7.76, 7.76. And last one we can we'll see the ground floor. This is the ground floor. So benzene P 16.38. So this column is 16.38 for axial, 16.38, and 4.03 and 4.03 for here, the 4.03 and 4.03, and last one is 16.38, and last one 16.3. These are the axial diagram of column which is taken which is starting from here. Now we can calculate the shear force, a shear force beam. So shear force beam we've been taken here. How will get this here? 2.12 and 5.13, as this is the CG we have been indicating here. So we have been found 2.12 and 2.56. How will get 2.12 plus 0.53? It will be 2.56 and upward. So if you want to understand this shear force of beam, so we have to understand this this diagram, which is given 2.12 is downward. So 2.12 is downward, and 0.53 is also downward. 0.53 is downward, and this is the we have been seeing here. This is the our CG, as we have been seeing in first picture, as I'm just erasing all this value. So these are the CG we have been seeing here. So the first two is left, and right is first two, and left side we have been found two column, and right side was two found two column. That's why it is left side is downward direction and upward is rightward direction. This is the CG. So we've been found 2.12 is gone downward, and there is no load and gone to the 0.53 and downward, and found 2.65, and if when gone in upward, when is gone in upward, then it is 0.53, and there is no load, and 0.53 into 2.01 is will be 2.01. So 2.12 it will be 2. So firstly it will go downward, there is no load, and go there and go 0.53 is 2.12 plus 0.53, it will be 2.65, and it will be go upward. Why upward? Because this is the our neutral axis, in that's why it will go upward. It will be deducting 0.53, which is 2.12, and there is no load, and also gone 2.12. This is the 2.12, and in this case we have been found this diagram. Okay, so let's see second one. We can see 7.76 and 1.94 is gone downward. So as we have been seeing 7.76, and it will be deducting deduct 2.12 as the upper axial load, and found 5.63, and in the same way 1.94, this is the 1.94 minus 0.53, so it will be 1.41. So 1.94 in 0.53 is also 1.41, and last one 7.76 minus 2.12, it will be 5.56. So 5.56 is in gone downward. So these are the 5.56 shear force diagram of beam is gone downward, and there is no load, and there is no load is gone here, and then is gone over, and again is gone downward is 1.41. So 5.56 plus 1.41, it will be 7.0 7.05. That's why it will be 7.05, and then it will be going upward as the why upward, this is the CG, that's why it will be going upward. So 7.0 or 7.05 minus 1.41, it will be 5.76. so 5.76 is here, and it will go on upward also. 5.64 minus 5.64, it will be 0. So that's why 5.64 is here. And last one, we can see the ground floor. We have been seen here, we have been found 16.38 from axial diagram. 16.38 minus will be upward, axial load of from upward. So we've been found 16.38 minus 7.76. How we'll get, this is the 7.76, just deducting here, and found 8.62. so 8.62 will go in upward. This is the 8.62. So 3.04, as we've been found 3.08 minus will be 1.94 from upward axial load. So it will be 2.13. And same way we can see 4.03 minus 1.94 is 2.04. And 16.38 we have been seen here. 16.38 minus 7.76 is, it will be 8.64. So if we go to the downward 8.62, and there is no load, so at first I'm going to the 8.62, and no load is here, and go down, downward is 2.12, which is bounced at 8.62 plus 2.115, it will be 10.74. so this is the value of 10.74, and then going upward 10.74 minus 2.115, it will be 8.22. so 8.62, and last one will go to the 8.62 minus 8.62, it will be 0. So these are the our shear force diagram of beam. It is taken from axial diagram. Okay, so I hope you can understand here. So now you can see the bending moment diagram of beam. How will get, it is shear force, it is the formula shear force L divided by 2. How will get, so let's see. Our shear force is found 2.12, and L divided by 2, L means 15 divided by 2, as we have been seen here. This is the 15, 10, 15. So that's why 15 divided by 2 in found 15.9, and in this case similar, we have been found 2.65 into 10 divided by 2, which is 13.2, and in this case is the same, which is 2.12 into 15 divided by 2, which is 15.9. So we have been seen here. How we'll get this, this is the also same, 15.62 into 5.64 into 15 divided by 2, which is 42.5, and 7.05 into 10 divided by 2, which is 35.5, and last one also remains same, 5.64 into 15 divided by 2, which is found 42.4. and we can see how we'll get 64.5, as we've been seeing this formula again and again. Beam in shear, this is the shear force of beam, 6.82 into L, how much L is given, is 15, and divided by 2, and found 16.4. I will get 53.8, it is B. What is the B? B is 10.74 into L, how much L is 10 in divided by 2 is 53.8. The same way is 64.8. So now we can see the very important. So how we'll get the bending moment of beam to the bending moment of column. Bending moment of C means column, it is taken from bending moment of beam. So it is very important. So as we have been seen is previously, the beam load will be transferred from column, and column load will be transferred from beam, as the cantilever method we have been seen here. So that's why beam bending moment of beam transfer to the column. In the previous in the another lecture we have been seeing the portal method, which is the column moment which is transferred to the beam. So in the same case we have been shown here. So we can see this is the beam, I'm just changing color for your better understand. You have to must be keep in mind this beam will be transferred the load to the column. How much it will be 15.9, so it is taken 15.9. This column is taken 15.9. So how much this load? So this load we have been seen here. This load, which is 13.2 plus 15.9. So these are the total load. So it will be the load will be carried in this column. So we have been seeing 15.9 into 13.2, which is 29.4. This is the 29.4 is taken this column. In the same way, this is the 15.9 and it is 13.2. This is the 13.2. This is the total moment. So it will take in this column. So it will, if we sum the 15.9 in 13.2, it will be 29.4. It taken this column. Okay, last one we have been seeing. This is the 15.9 only imposed in this column. That's why it will be 15.9 will be imposed in column. So next one is very important. So you have to give attention that we have been found 15.9 is here. So it will be also 15.9 is here. So we have been found here 42.4 is imposed this column. So we have this column also. This column is carry the 42.4 the total load, as we have been seen here 42.4, but we have already 15.9. So these are the 15.9. I'm just changing color. This is the 15.9, as this is in here that 15.9. So if you deduct 15.9 minus 42.4, then we will be found 26.5. So these are the important. So I will get this value 26.5 and this value is 15.9 and total value is 42.4. Okay, and let's see another. We can see this portion 29.5, so it will be also obviously 29.5. On the other hand, we can see here this here, this is the 35.3 and these are the 42. So how much is total load? So if we calculate here the 35.3 plus 42.5, so it will be 77.7. So 77.7 will be distributed this column. So as we have already here 29.5 is 29.4 is here. So if we deduct 29.4 from 77.7, we deducted 29.4, then how much it will be? Minus 29.14. So it will be 19.46. So this value we can see this value 19.46. This also 19.46. Keep in mind here. So I am saying again as the same interior column. So this is the 29.4. It will be 29.4. So how we'll get the 48.5? So we know the total load it will be 19.46. So it will be mistaken even here. So it will be value is here and this value also here. Okay, so let's see. So we have already 29.4 here, 29.4, but we have total how much? Total we have been calculating here. Here 35. Sorry, these are not 35. This is the maybe this is right. I'm just checking reverse check. This is the 42. So we've been taking the first 42 is here. This is the 42.4. So 42.4 plus this this point how much is 35.5. So it will be total load 35.3. So plus 35.3. So this is the total load 77.5. So 77.5 is taken this column. Okay, so 77.5 will be taken this column, and of them we have already 29.4. So we have we have 29.4. So now we'll deducting minus 29.14. So the value will be 48.36. 48.36, this means 48.5. That's why the value will be remaining this value 48.5. So this also 48.5, and 26. How we'll get the 26? So we have been seen here 42. These are the 42. These are the 42. So the total column is taken the 42. Okay, so I'm just taking 42.4, and of them it is already contained 15.9. So I'm just deducting this value minus 15.9. So how much will be? It will 26.5. So that's why it will be 26.5 is taken this column. Okay, I hope that you can understand. I'm just summarize. I'm just saying again. So it is taken 68.4. So this is the 68.4 will be taken this column, the total load 68.4. So this column will be taken, this will be total 68.4. So we have been how much? 64.6. So we have already I'm just changing color for your better understand. Okay, this value have been 26.5 is also 26.5. So our total value was 64.6. It will be deducting 26.5 minus 26.5. Then we have been found 38.1. So remaining value is 38.1 this. Okay, so second one we have been seen here. If the 68.4 is here, it will be also 64.8, 64.6. So 64.6 plus 59, the total value will be how much? I'm just adding here 64.6 plus 53.8. So our total value is 118. So 118, we have 118, and we have already here 48.5. So here also 48.5. So if we deduct the 48.5, then it will be 69.9. So these are the 69.9. So we can see here, you can calculate in the same way as we have been found 53. This is the 53 and 68, the total value is taken here. Of them we have been found deducting the 48, and we have been found 69.9. okay, this will be bending moment of column. So we can see the shear force of the column. How will get the shear force of the column? 2m. M means bending moment divided by L. L means this portion. Okay, 2 into L, how much? We can see 2 into M is 15.9 divided by L. L is how much? L is 15. So we've been found 2 point L, how much is L? L is also 15. It will be H, sorry for that. 2m divided by H. Okay, so I'm saying here 2 into m is how much? 15.9 divided by H. H is how much? We have been seen here, the graph is 10, that's why it will be divided by 10. Okay, so in the same way we can found we've been found the next value. The second value is here, 2 into m. M means 2 into if we 2 into m means 29.4 divided by 10. Then we have been found 5.82. These are the value of 5.82. In the same way we can calculate here this value, and if we finding here this value 2 into 26.5 divided by 10 and found 5.31, and in this case we can found here how will get this value? This 2 into m means 26 2 into 20 2 into 38.1 divided by 10 and found this value. So in this case we can found the shear force of the column. Okay, so this lecture is in that if you want the irregular shape of the building, then you can say here the use the cantilever method of the axial force diagram. The column is given short, is the load is given here. First of all we have to taking the CG and x1 x2 x3 also, and taking the this load member load and this member load also, and finding after the axial load we are just putting the axial load is here. All the after the axial load we just drag the shear force in taking the shear force moment is here, and after the shear force then we have been finding the bending moment of beam is here, which is to B into L divided by 2, and after finding the bending moment then we can find bending moment of the column for balance purposes. You can just take a look, but if you understand this then I will be grateful. So now this is our the prime object of this lecture, for example of the analysis multi-storied building. Now we will compare the result between portal method and cantilever method. Okay, let's see here. This is the portal method we have been shown here. Okay, I'm just taking snapping picture. Okay, so this is the portal method. I'm just portal. Okay, now we have been seen this are the cantilever method. So At first, I will show the bending moment of beam. So you can see the, okay. At first, I will show the bending moment of column. So this is the bending moment of column. I'm just erasing some below. Okay. So this is the portal method we have been shown here. Bending moment of column. So bending moment of column, uh, we've been found 15, but it is why we are comparing here, because the wall load is given the cantilever method, all the dimension and all the load are same, which is 18, 12, 6, and the distance is 15, 15, 15, and 10, then 12. If you go to the portal method, this is the portal method. So if we go to the portal method, the 18, 12, 6, and the distance of 15, 10, 10, and height is 10, 10, 12. And for cantilever method, the same value, and distance is same, and the height of also same. We just check the value which is greater and which is lower. So this is the portal. So you can see the portal, uh, the bending moment of column we have been found 15. On the other hand, in the right portion we found 15.9, and we've been found 25, and we've been found 16, we've been found 36, and here we've been found 36.1. So we can see the bending moment of the cantilever method is much greater, and this of the portal method is lower. This is the lower value. Okay. So we can see here the portal method. uh, Here the bending moment of cantilever of beam, I'm just taking here. So we've been found, this is the 15 for portal method, we've been found 15. On the other hand, we have found here 15.9 in cantilever method. So and second one we have been seen here, we have been found 40 in portal method. In cantilever method we have been found 42.4. In portal method we have been found 60 in ground floor, and we have been found in cantilever method is 64.6. So we can see the cantilever method is bending moment is much higher than portal method. So that's all. If you have any question, then let me know. If you want to see the shear, then you can also compare the shear. So you can see the column shear, which is 15. Column shear of the portal method we can found here how much, 15, 25, and 36. Sorry, these are the beam, not shear. The shear of the column, this is 356, shear column 356, shear column 356, and it will be 3.8, 5.8, and 6.3. So you can see that this value also greater. Cantilever portion value also greater, as we have been seeing here. This is the 3, 5, and 6, and we have been shown here 3.8 and 5.36 and 3.6. So we can see the cantilever method is much better of the shear force also. So that's why I have been writing cantilever method is greater than portal method value. So if you have any question, then let me know. I will try to discuss again and again after. If you have any question, then let me know. Thank you everyone. Thank you. So if you question which method you will use In the approximate method, I will personally recommend you can use the cantilever method, as cantilever method is found in the much more below compared to the portal method.